So hello everyone. In this video, I was talking about calculation of FIFO depth. So this video basically made by Made Easy. Okay. So accomplished by Putta Satish, whatever his name. So give him to credit all of for this PDF. Okay. So FIFO depth calculation basically when it's required, so that's we are understood that we will try to be understood. So why need to uh, employ an asynchronous FIFO between two modules working at different clock domain when some amount of data has been transmitted from one module to other to avoid the data loss. FIFO is required only when you are slow at reading and fast in writing to buffer the data which is not read by the slower module. Okay. So suppose here is my one block and here is my another block. So we just give frequency different frequency to work. So it's work at clock 1. It's work at clock 2. Suppose my clock 1 frequency is much higher than clock 2. So what happened? This module or block that deliver the data fast, but this block can't receive the data at the same speed that can't receive, so it's failed. So this block can't receive the data, whatever the data uh, output by this block that goes to here. But what happened in here? Here happened that this block can't receive the same data in same rate, so some data mismatch will be happened here. Okay. So for that reason we use FIFO. FIFO is what? Fast in, fast out. So A for fast, in for in, and again fast out. Okay. So the depth. So this is basically the size of FIFO should be in such a way that the FIFO can store all the data which is not read by the slower module. FIFO will only work if the data comes in burst. Okay, work in a data comes in a burst. You can't have continuous data in and out. If there is a continuous flow of data, then the size of the FIFO required should be infinite. You need to know the burst rate, burst rate, burst size. Okay, a little bit I have a problem in my tongue, so that I can uh, pronounce this word properly. So just understood. This is burst rate and burst size, frequencies, etc. to determine the appropriate size of FIFO. So basically, what in this object oriented, it's bad object oriented actually. Okay, so what they try to burst, BURST, something like that, burst. So burst means basically, suppose your data like in analogy, what do I give you analogy that suppose at a single time, like this is suppose a counter, this is counter, but these counters, if the one person can go, then it's okay, one by one. But suppose the lots of people are goes at the same time, like 10 people goes this counter at the same time, this is counter and 10 people are in front of the counter, so it's will like jump is happened, so that type of things, that is called burst. If suppose the 10 people's like doing one by one row, and here is a counter, like one people go and one is out, one will go, one is out. So in these type of things, then uh, FIFO need like infinite type of memory. But that's the not problem. Problem is like the bash type. Bash type data like 10 type 10 data goes at the same time, but after sometimes like there is no such data are available. Okay, so 10 data that can handle, but the problem is this is go at a single time. So that's the problem. Like if I check my rate, data flow rate from block 1 to block 2, that times like it's will increases. So that's the problem. Like even if like the continuously the frequency rate is second is slow, first is high, first block like which will actually deliver the data to the second block or module which actually accept the data. If it is frequency low, it is high, and it goes like continuously one to one. So there, then that case you need a infinite memory, uh, FIFO. But that's the not comes to the like FIFO depth problem. That is different path. So that's the not a FIFO depth problem. FIFO depth problem is my data is a going to in a burst mode. Burst mode means like 10 package goes in a single time, and after that it not going. So at that time the we need a FIFO. Okay, that time we need a FIFO. So burst mode, only burst mode can condition the we need FIFO. The logic is fixing the size of the FIFO is to find the number of data items which are not read in a period in which writing process is done in order words. FIFO depth will be equal to the number of data items that are left without reading. With this logic, I tried to fix the size of FIFO required in different scenarios without using any standard formulas which can be used in every scenario. So there are no such scenario, like every time every scenario the FIFO depth counting is different. So the logic in fixing the size of FIFO is find the number of data items which are not read in a period in which writing process is done. In other words, FIFO depth will be equal the number of data items that are left without reading. With this logic, I tried to fix the size of FIFO required in different scenarios without using any standard. So formulas which can be used in every scenarios. Okay. So any standard formulas are not required. So just for understanding the scenario, what the scenario they are asking, and according to the scenarios just try to give the answer. Okay, that's all. The following example describe the different possible scenarios in which asynchronous FIFO is required. In the following example, I consider that the module A wants to send say some data to the module B. So here is module A and module B. So module is try to send some data to module B. So this is the basically in every case this two will comes. So case one. Okay. So now case one where FA greater than FE, FB. So FA greater than FB means the frequency of module A greater than frequency of module B with no idle cycle in both write and read. So The writing frequency of FA is 80 megahertz and the reading frequency of FB. So basically it's a 50 megahertz. So at burst length, number of data items to be transferred 120. So basically 120 data should be transferred, and there are no idle cycle in both reading and writing, which means that all the item in the burst will be written and read in consecutive clock cycle. Okay, the burst will be written and read in the consecutive clock cycle, all the items. Okay, so here is the time required to write one data item. So here is time required to write one data item, that is one item. So the time required write one data item 1 by 180 megahertz. So basically this is the time of ta what the like required time. So basically the required time is 1 by 80 megahertz. So that is 12.5 nanosecond. And time required to write all the data in the burst, that is, so total is 120, and my time required for 12.5 nanoseconds, so it is like 1500 nanoseconds it's required to write the data. And time to time required to read one data item. So writing frequency this and reading frequency this. Okay. Okay, so time required to read the data item is 1 by 50 megahertz, that is 20 nanoseconds. So that like 1 by 50, so 20 nanosecond it is 50 megahertz. So it's 20 nanosecond, and so for every 20 nanosecond, the module B is going to read one data every 20 nanoseconds. So okay, in the burst. So in a period of 1500 nanosecond, 120 number of data items can be written, and the number of data items can be read in duration is 1500 nanosecond. So that uh, 75 is like 1500 nanosecond by 20, so 75. So what the mismatch is happened here, like the remaining number of bytes to be stored in the FIFO, 120 minus 75, that is 45. So FIFO, which has to be scenario, must be capable of storing 45 data items. Okay. Okay, scenario was like 80 megahertz. So this will the writing speed of this A block and reading speed of this B block or module. Here writing speed is like 80 megahertz. So that is I think 15, sorry 12.5. So 1 by 80, actually 1 by 80 megahertz. So that is 12.5 nanosecond. And the reading speed of this block is 50 megahertz. So basically 1 by 50 megahertz means the time required for 20 nanosecond. Okay, so this block deliver the data at 12.5 nanosecond, but this required to capture the data or read the data at 20 nanosecond. So what the extra time that required, so how to solve this problem? So we need a FIFO, that what's the FIFO depth is required, so that any kind of data that will be lost uh, can't lost. So here is my FIFO. So this is 12.5, and total number. What is the total number? That is 120. So here is 120. So that's Total 12.5 windows, so it is 1500 nanosecond. So that 1500 nanosecond. So now, if my in 1500 nanosecond, how many how many data, how many byte this block B, this module B will read. Okay, let's check. So that's the one byte data that required times is 20 nanoseconds. So for 1500 nanosecond, how many byte of data that B module can read? So that is 1500 by 25, that is 75. So how many data will be lost? So that's the FIFO depth. So 120 is my byte number of data. The number of data times to be transferred 120. So burst length equal to number of data that will be transferred. So 120 minus 75. So that is like 70 45. So my FIFO depth is 45. This is the answer. My FIFO depth is 45. Case 2. So I hope the case 1 will be understandable for everyone. Case 2, FA greater than FB with one cycle delay between two successive reads and writes. FA greater than FB with one cycle delays between two successive reads and writes. So this is just create some sort of confusion. This scenario has no way difference from the previous scenario case 1, because always there will be one clock cycle delay between two successive reads and writes. So the approach is same as earlier one. So if you with one cycle delay, okay, one cycle delay. Basically, what is try to say, like if my clock cycle is this, okay. So one clock cycle is delay. So whatever the here, so that will appears in here. So suppose my capturing speed clock cycle also be same, like module B frequency also same. But in this clock cycle, if it is want to deliver the data, so it's not possible to capture in this cycle. So it's just want to say that the previous problem but in a different way. That if my clock is a positive edge trigger, like the module is positive edge triggered, so this in this time the positive edge trigger data will be transferred. It's like give the one to block A, so that it will active and it try to send the data. But what the problems, like in the next clock cycle, the module B, here B block, that will capture the data. So it's not a it's the same problem like previous one. Okay, so you need not to be worry about the like FA greater than FE with one clock cycle delay between two successive reads and writes. Okay, so just the previous problem, and here the case 2 is not that much elaborate. So basically the same problem, and now is case 3. What is the case 3? Case 3 is FA greater than FB with ideal cycles in both write and read. So FA and FB write ideal cycles in both write and read. So ideal cycle. Okay. Okay. Writing frequency is 80 megahertz and reading frequency is 50 megahertz. Okay. And brass length is 120. Number of ideal cycle between two successive writes is 1. Number of cycles between two successive read is 3. Number of ideal cycle between two successive read is 3, and number of ideal cycle between two successive write is 1. it's like a little bit different. So let's go to the solution. So the number of cycles between two successive write is one clock cycle. It means that after writing one data, module A is waiting up one clock cycle to initiate the next write. So it can be understood that for every two clock cycle, one data is written. So the number of idle cycle between two successive writes is one clock cycle. It means that after writing one data, module A is waiting for one clock cycle for initiate the next write. So it can be understood that for every two clock cycle, one data is written. Every two clock cycle, one data is written. The number of idle cycle between two successive writes is one clock cycle. It means that after writing one data, module A is waiting for one clock cycle to initiate the next write. So it can be understood that for every two clock cycle, one data is written. Next, we'll understood the number of idle cycle between two successive read in three clock cycle. The number of idle cycle between two successive read is three clock cycle. It means that after reading one data, module B is waiting for three clock cycles to initiate the next read. So it can be understood that for every four clock cycle, one data is read. Time required to writing one data item equal to 2 into 1 by 80 megahertz equal to 25 nanosecond. Time required to write one data item equal to 2 multiply 1 by 80 megahertz. So it is 25 nanosecond. Time required to one data item. Okay. The problem is if A greater than B with idle cycle in both write and read, but burst length number of data items to be transferred 120, number of idle cycle between two successive write is 1, and number of idle cycle between two successive read is 3. Number of idle cycles to successive read is 3. Okay. Okay, let's go through the problem once time. So this is my idle clock, and I assume the both are same idle clock, read and write. So here is the write and here is the read. Both are same, but the problem is the idle cycle between two successive write is 1. Okay. The idle cycle between two successive write. Number of idle cycle between two successive write is 1. So number of cycles. So here is one cycle and here is one. So here is one another like this. And number of cycles between two successive read is 3. Okay. So okay, I go through a little bit. So here is my clock like this. So if my read is happened here, if my reading fast reading is happened here. So this is one clock cycle, this is two clock cycle, here two, here is three and three reads. O, one, so one, two, three. एक दो and here again. So three clock cycle no. So here is one to two, one, two, and three here. And this time. So total three. So it's like four. Four cycle required. Four cycle required for one read. That's the concept behind that. Okay, understood. So basically, what the try to say in this problem? Okay, let's explain. Okay. So this is my clock of something like that. That this is my launching clock. If I say this is my right clock. Okay, right clock. So right clock is telling us that my first clock is right here and next clock is right here. So between them one clock cycle is extra required. So here is my first clock, here is my first clock, and here is my second clock. What happened? I don't know what problem with happened. I don't know what's the problem with happened with this. Just a second. Okay. Mm. So here is positive edge triggering. Here is also positive edge triggering, and here is also positive triggering. But according to the questions, that in this period, my right clock cycle enable, so it deliver the data, and here also it deliver the data. But between this and this, one extra clock is required. So in this period, there is no data will be sent. Okay. So this is the questions they will ask in the like problems number three. So here is total one clock cycle. From here to here, this is one clock cycle, and yeah. So and this is another. So here you need to be one extra clock cycle. Okay. So that's the questions asked. So a total number of clock that is required for two for sending one data. And what told in uh, reading data case. Okay, in reading, here is the clock again, something like that. This is the clock. So here data could not be read, but I assumed that okay, in previous there is some cycle. Okay, So after one clock cycle, the data will read. Just because like at the same cycle, suppose this cycle my data will be like write for data from module A to module B. So in this period, module B can't receive the data. So we need a extra cycle like that the case 2 we already seen. So that suppose my reading data is from here. So like we need a positive edge clock so that my reading data will be captured from this. But between like 3 cycle will be extra. So here 1, here 2, here 3, here sorry, mm, this is 1, sorry, this is 1, so 2, and this is 3. Okay, so we need a 3 cycle. This, so we need 2 and 3 and extra cycle that is required also. So here is 3. Okay, so up to this 1, 2, 3. Up to this, my data will not read. In this period, when positive edge clock comes, so my data will read. So this is the problem. Like in when we write the data, so only one delay, like 2 cycles will be required, but here total my 4 cycle will be required. Just see from here to here. So my data 4 required, total 4. Here once 1, 2, 3, and 4. Total 4 cycle will be required. I hope now this concept is clear. So now try to solve the problem. Okay, what's the problem? So FA is my 80 megahertz. So 1 by 80 megahertz. So one clock cycle that is 12.5 nanosecond, but it's required two. So successive writes is one, basically between two successive writes. So basically it required two clock cycles. So my total time is for sending writing one data is 12.5 into 2, so that is 25 nanosecond for sending. And what is the receiving or reading? So that is module B. Module B, what the required module B is like required for 1 by 15 hertz, 50 megahertz. So it's required 20, I think 50. So 5 into, so 20 nanosecond. And what is the total time required for sending? This is for one clock cycle. Okay, so my data receiving time is 4 clock cycles, so 20 into 4, that is 80 nanosecond my receiving. And what is the total time required to sending or write the data? That is 25 nanosecond. We multiply how many burst length? What the burst length? Burst length is my 120. And what is the receiving end data, like clock cycle like time required? That is 80 nanosecond. So basically by 80, and this 80 actually basically 20 nanosecond for one cycle, but it required 4 cycle for reading the data. So that's why it's 80. So 80, and I think this will cut 8. So it's will like 1.5. So 1.5 means 25 into 1.5, that is 37.5. But the problem is 37.5 point 0.5 can't read because the data, how it's to be point 0.5 read. So it is 37. Only 37 data can read. So what is the length of the FIFO? So FIFO depth is my FIFO depth equal to 120 minus 37. That is 83. So 83 is answer here. Now problem number 4. that is case 4 also. So now also the FA greater than FB with the duty cycle given for with respect to enable and read enable. So writing frequency FA is 80 megahertz. So previous as, but duty cycle of the write enable is 50% equal to half, and duty cycle with respect to write enable is 25%, means 1 by 4th. Okay. So this scenario is now different from the previous scenario case 3 because it is in this case also one data item. So I will tell what happened in here. So suppose this is my clock. It look like 50% on and 50% off. So this is called my 50% duty cycle. If suppose my clock look like this, here is my clock and one, two, three. So it's like one fourth. One fourth time it's on and rest of the time it's off. So basically this is my one fourth duty cycle. Basically this is the concept, and so this is one fourth duty cycle and this is one half duty cycle. And what's the problem? So burst length are also like previous problem is same, but the changes is here 50% and 25%. So these scenarios no way different from the previous scenario. Because in this case also one data items will be written in two clock cycles and okay, got it. So if my duty cycle is less, so the problem is it requires two clock cycle for uh, receiving the same amount of data that which will actually the deliver in the one clock cycle in the block or module A. Okay. So my sending in data. So okay, now try to solve the problem. So here is my 80 megahertz, so that is 12.5 nanosecond, and 50 megahertz, that is 20 nanosecond. So this is my writing speed. Writing speed. So in one clock cycle, the writing speed will be like fulfilled or satisfied. So there are no problem. But the problem is in here. So my cycle is 20 nanosecond, but the problem is my duty cycle is like not 50%, not match with the my right enable signal. So the problem is here that my duty cycle is the create the problem, so that what we do, that my total time will be required 2 into 2, 20, so that will be 40 nanosecond. So in 12.5 nanosecond and 120, so 120 into 12.5, my total, like if I counting the FIFO depth, so 120 into 12.5 by, and what is the total time required for uh, retrieving or receiving or reading one data, that is 40 nanosecond. So 40 into 120, that will be 3, and 3 into 12.5, that is also with 37.5. So 37.5 is not possible, so 37. Here also 83 answer. I hope the 83 answer here. Okay, so solution, the scenario was no way different from the previous scenario, case 3, because this case also the one data item will be written in two clock cycle, two clock cycle, and one data is item will be read in four clock cycle. So note case 2 and case 4 are explained to make everyone understand that the same question can be asked in a different way. Okay, so that the note. Now case 5. In case 5, what they tell, that my frequency of A is less than frequency of B. So with no ideal cycles in both write and read. So there are no ideal cycle. The delay between two consecutive writes and read is one cycle. So read in one cycle, one clock cycle. So writing frequency FA equal to 30 megahertz and reading frequency FB equal to 50 megahertz. Burst length number of data items to be transferred 120. There are no idle cycles in both reading and writing, which means that all items in the burst will be write enable and read in consecutive clock cycle. In this case, FIFO of depth 1 will be sufficient because there will not be any data loss since the reading is faster than writing. Okay, so here is the no problem. Actually, basically my FA less than FB. So this is my module A and this is my module B. So here the sending end or write data is much slower than reading data. So if suppose someone reading speed is very high compared to, like suppose me and my friend, two condition A and B. So A is me and B is my friend. So I am writing like I am Pallapal. Okay. So I am Pallapal and my friend speed reading speed is very high. Like I am Pallapal. So he before I started he understood. Okay. So just I write I and he speak I. And when I write A, he speak A. When I write A, so this kind of thing. So this is the problem. So basically, this is not a problem anymore because the reading speed data is much higher than uh, FA. So only for burst data, like burst in a burst mode, like if you are sending 120 data, so only one FIFO depth is required because suppose this is my clock cycle. Okay, this is my clock cycle. So you start to store the data just because of suppose this is my again the same even I am not saying the faster. So this data will take this much time. So for this much time we need a 1 FIFO depth. That's all. And case number 6. So FA less than FB with ideal cycle in both write and read. So again another condition FA where my block A module A frequency is less compared to module B, and the idle cycle in both write and read. Duty cycle of write enable and read enable can also be given in this type of question. Okay, here's the main uh, let's twist of this question, like duty cycle of write enable and read enable. So that makes the changes of difference. Okay, let's go through the question. So I think previously we did one type of question like two successive write is one, two successive read is three. So we understood here also like two successive rates or three. Here is two successive rates. So basically here one between one there is between two successive rate one clock cycle is extra. Okay, and here is four. So this concept, and what is this concept like? My clock cycle between two successive write is one, so it's one means it's like it's total time. Okay, here I try to solve the problem. Okay, so my fa is 30 megahertz, so 1 by 30, that is my uh, megahertz. So basically something like that. I take it in a like second, 30 nanosecond. Okay, so this is my 1 by 30. No, I can't write this way. So 1 by 30 megahertz. So 1000 by 30 nanosecond. Previously, what happened? Previously, 80 megahertz. So that 80, 12.5 nanosecond. Hmm. So this is my milli, micro, giga, giga, megahertz. Okay. So nanosecond, and so the and other is what? My reading, but there is one cycle. So here is two times because two clock cycle required for writing the data. So here is two, and my reading. What is the reading frequency? So reading frequency 1 by 50. So 1000 by 50 a clock cycle means nanosecond, and what the total cycle required for reading the data, that is 4. So this is around approx 80 whatever. So now what I did, that I need to perform the calculation. So that is 120 data. So total is 2 into 1000 by 30 into 120. So 3 into 4 by, so that is the total time required for total time required to writing the data by the for one data required time. So 4, this is 80. It's like 50 into 20, 20 and 4 80 nanoseconds. So this is 80. So 1000 4, so 4000 8000, 8000 by 80. So this is 100. So if 100 data will be 100 data can be read by module B. So how many data will be left? So that is 120 minus 100. So that is 20. So FIFO depth, so minimum depth of FIFO depth is 20. This is the problem. I hope the concept is clear because previously I told about the clock cycle concept. Like two successive writes, there are between one I like no number of ideal cycles between two successive write is one. So this concept is clear. Now case 7. So what is the case? Let's see. Now the both clock are same, F equal to FB with no ideal cycles in both. So ideal cycles will be not there in both writes and read. The delay between two consecutive write and read is one clock cycle. Okay, that's so there are no ideal cycles in both reading and writing, which means that all the items in the burst will be written, write enable and read in consecutive clock cycle. So F equal to FB with no ideal cycle in both write and read. The delay between two consecutive write and reads is one clock cycle. So there are one clock cycle, two consecutive write and reads. So writing frequency F equal to FB equal to 30 megahertz. Burst length is 120. There are no ideal cycle in both reading and writing, which means that all items in the burst will be write enable and read in consecutive clock cycles. So FIFO is not required there is no phase difference between clock and clock AB. So if FIFO depth 1 will be sufficient. So yeah, this concept is very much clear. So what here is told, that I had two block A, block B, but the clock cycle is not ideal. So here the what the frequency of clock cycle, that is 30 megahertz. 30 megahertz both. Okay, whatever the frequency goes here. But the thing is, there is in reading and writing in burst which will return and read in consecutive cycle. So the delay between two consecutive writes and read is acha. This is one clock cycle. So this problem, this this concept. Okay, so here's also kept here from here to here. Only one data will be right. So flip flop. So module A that only write one data. So if I want to read the data, so here the same clock like this, like this, like this. So here I want to capture the read the data. So only from here to here I need to like at least I need to capture data, so that only one flip flop required to hold this data to this. Okay, this is will take little bit time, so that one flip flop one FIFO is FIFO depth is enough. So FIFO depth one is will be sufficient. Now case 8. So my again the FA and FB with ideal cycles, both write and read. Duty cycle of write enable and read enable can also be given these type of questions. Okay. Okay, between two successive reads. So writing frequency FA equal to 50 megahertz, FB equal to 50 megahertz. So number of data items to be transferred is 120, and the ideal cycle between two successive write is 1 and 3. So that's I already told. So this is the problem. Let's see. So here 50 megahertz means 20 milli, 20 nanosecond, and the successive write is 2. So 2 for sending one data is 2. So 40 into my 120 by what is that to the 3, so 3 plus 4 into 20. So 20 to 2 to 60. So 60 FIFO depth is 60. FIFO depth is 60. Okay. And case number 9, the data rates are given as flows. Write data is 80 data per 100 clock cycle. 100 clock. So randomization of 20 datas. Okay. Outgoing data 8 data per 10 clock. So burst size. Okay. So here total my 8 data, 80 data but 100 clock cycle. Okay. So in 100 clock cycle, the 80 data will write, but the outgoing data, means like the receiving end, like in the module B, the outgoing data is 8 per 10 clock. Okay, 8 per 10 clock. So the given specifications are need to be required frequency. So the given specification indicate that the writing frequency is equal to the reading frequency, but both reading and writing can happen at any random instance with the constant. So the I think suppose my this part of case 1 is writing and this is idle, 82 20 like something like that, and case 2 this also be one case. Okay, and case 3 write like this, case 4 so here and here, case 5 like something like that, this will be randomly. So the following are the observation from the above diagram. So case 1, number of cycles taken to complete write 200, and number of cycles taken to complete write 200, 200, 200. That will be the cases. And but number of cycles taken to complete write in case 3, that is 180. So how it's 180? Okay, for here to here, so the for that reason I think 180, and 4 is also 4 is 160. Okay, total complete the data. And why it's like we take the 200? Let's see. For checking purpose, like I think they just for number of cycles to take to complete right or like this, and number 5 it is 200. So to obtain safer FIFO size, we need to consider the worst case scenario for the data transfer across FIFO under consideration to avoid data loss. So for worst case scenario, the data transfer between the data rate between write and read should be maximum. Hence, for write operation, maximum data rate should be considered. For read operation, minimum data rate should be considered. Okay, the maximum data rate for the write in case is 4. Write operation is completed in minimum number of cycle in this case, so consider the case 4 for further calculations. So in period 160 clock cycle, 160 number of data items can be written. The data rate for the read 8 data per 10 clock cycles. The number of data items can be read in a period 160 clock cycle. 160 clock cycle. So 160 into 80 by 10. So that is 128. And the remaining number of bytes to be stored, the FIFO 160 minus 128, that is 32. So FIFO depth is 32 data. Okay. So how can it be possible? Let's assume to obtain safer FIFO size, we need to consider the worst case scenario for the data transfer across the FIFO under consideration to avoid the data loss. For worst case scenario, the difference between the data rate between write and read should be maximum. Write and read should be maximum. Hence, for write operation, maximum data rate should be. For write operation, maximum data rate should be considered, and for read operation, minimum data rate should be considered. For write operation, the maximum data should be considered, and for read operation, minimum data should be considered. Okay, the maximum data rate for the write in case is 4. In case of write operation completed in minimum number of cycles, in this case. Okay, got it. So that is 160. So my write like this is will be also be happen. So total 160. Okay, got understood. I understood this concept. Okay, basically we have a 100. In 100 cycles we send 80 data. Okay, so 80 by 100, but the problem is we don't know that the what the randomly it can be sent. So there are four conditions. Suppose in here there is no problem, like you if you 100, so total 100 cycle it will be cover. In here also 100 cover. In here also be like 100 approx cover, but the worst case is this. Suppose it start from here and it goes to here, then this is 160. So this is the problem. So total 160 bit of data if module 1 send it, then what we do? So that is the problem. So 160 and how many, and the scenario for the worst case. So for receiving end, this is the worst case, right? For receiving end, because if the data read like this to this, then it's the best case, like 16 data at consecutively it's received. But this is the best case. So worst case is this. So my 8 out of 10 data will be received. So for this, we had 160 into 8 by 10. So that is 128 data. Normally we can be read, but how many data will be left? So 160 minus 128, that is 32 data we can't read. So that our flip flop, sorry, our FIFO size, FIFO depth is 32. Actually, 32 depth required for FIFO. So the minimum depth of the FIFO should be 32. And the last problem, that is number 10. Specification can be given a different way. Understanding the specification is important here. So given the following FIFO rules, how deep does the FIFO need to be prevent underflow or overflow? So this is the question. So frequency of clock A equal to frequency of clock B by 4. So frequency, okay, so suppose my frequency of clock A is suppose my 100, and frequency of clock B is my, so that, okay, frequency of clock B by 4. Okay, then this is my f of a. Okay, f of a equal to 100, then f of b equal to by 400, because f of a equal to f of b by 4. So most of the time this is the part maybe people are doing wrong, that they assume that if a is my 100, so my frequency of clock b is 25. But according to questions, uh, if my if b equal to 400, then it's like divided 4 by 4, then if is my 100. Okay, and period enable b equal to period clock a into 100. Period of enable, okay, and period of duty cycle of enable b equal to 25%. Okay, okay, the problem I will understood what the problem is here. Basically, so suppose my frequency of a, frequency of a duty cycle, sorry, time, period of enable b equal to period of clock a into 100. So basically period enable b enable b period will be same as period of clock a. Okay, suppose this is my clock a, this is my clock a, and what the saying, that frequency of clock b, okay, so this is if a is 100, so period of enable b equal to period of clock a into 100. So this is 100 hertz. So period is basically 20, sorry, 100 hertz means 10 nanosecond, 10 nanosecond. But the problem is that period is same. So if my period is same, then how it can be period of enable b? Enable b, okay, enable b is same as period of clock a. Clock a, period of clock a. Okay, period of clock A, that is so 400 nanosecond. Frequency is 400. If my 400, okay, So this is the problem. I think frequency 400 so that my like this. I think like this. This is the case. And what it other says duty cycle is enable of B is 25%. So 25% duty cycle. So this is my 25%. So lot of conditions in here. Frequency of enable A, frequency of clock P by 4, period of enable. Both are different, I think. Periods of enable B and clock of B. So both are different. Enable period is equal to 100%. So frequency of clock A. So this is 100, this is 500, this is 400. Frequency of B. But entire period enable B is on. Enable B is on. So not a problem. But the duty cycle is 25%. So I need more cycle. How many cycles I required? So here's the also one problem. Like let's see the solution. So here we take 100 brushed publication. The brushed length is 100. So assume clock A is 125 megahertz. So that's and okay 25 megahertz. So my sending end in the specimen given brush, the length of the specified indirectly. The brush length is 100. So time required for write one data item is 1 by 100. So required 1 by 20 14 nanosecond, and time required for write all the brush data 4,000 nanosecond. But the duty cycle is enable B is 25%. Duty cycle of enable B is 25%. Means that out of 400,000 nanosecond which the writing process is complete, reading is done only in period of 1,100 nanoseconds. So 25% of 4,000 nanoseconds. So that FIFO should be capable of holding the data which been written in the remaining 3,000 nanosecond. And the number of data items can be read in period of 3,000 nanosecond. That is 3,000 nanosecond by 40 nanosecond. So 75. But why it is 40 nanosecond? That's the question. Mm. So the FIFO should be here. Why is 40? That's the problem. Because it's the clock B, no? So if clock B, then why it's not 100 megahertz? If it is 100 megahertz, then Okay. Understood. Can be read. So this frequency of clock B is much higher than clock A. So if 3000 nanosecond, so 40 nanosecond it will be send the in 40 nanosecond that the data sended. So in 40 nanosecond it data sended, so 75 data will be read because it not depends on the clock B, because clock B is much higher than clock A. So that the problem is whatever the data sent, just receive. Whatever the data sent, receive. But the problem is not clock B. Problem is that this 3000 nanosecond by 40 nanosecond, so 75 data will be sent and it will be also received. But how many data will be not received still yet? So that is the minimum depth of the FIFO should be 75. That's not the problem of clock receiver. That's the problem of sender, the problems of sender. Okay. And the enable, that is 25%, like 25% duty cycle. So out of 4000, it will be receive only 1000 nanosecond. 1000 nanosecond it will be on. So 1000 nanosecond times it data, what, how many data will be received. So that is on, and rest of the in 3000 nanosecond it will be for hold or need a FIFO depth. Got it. So I hope the FIFO depth problems will be now clear, that the like 10 type of problems may ask in interview or some examinations. So that's all from my side, guys.